Greetings, dear learners. I am faculty of physics at SRN International School, Jagatpura, Jaipur. Today we will learn a chapter taken from grade 11th physics, work, energy and power. So our objective for today's class is we will learn today the following topics. First, we will learn about the definition of work, energy and power. Then how to measure work done, calculate work done by variable force, define kinetic and potential energy. Then we will learn the work energy theorem. Also we will calculate work energy theorem for variable force, and the remaining topic will be discussed in the next video. So let's start the video, starting from the definition of work. So here we have seen the various examples in today's daily life in which you will observe a boy swimming in the swimming pool, a boy is running, a man is lifting a load. All these examples constitute of work, energy and power. So we will talk about it one by one. So let's talk about work. According to the definition of work, the work by a force is defined as the product of component of force in the direction of displacement and the magnitude of this displacement. So work done can be represented as force into displacement and the horizontal component of force, that is F cos theta into displacement. So here in this two images we have the force applied to displace the object either at angle 0 degree to the displacement or angle 45 or any other angle with the displacement. Now next is kinetic energy. So kinetic energy is the energy possessed by a body by virtue of its motion. And the formula is half mv square. So flowing water, flying birds are the example of kinetic energy. Okay, so energy possessed by a body due to its motion is known as kinetic energy. Now let's talk about the example. So we have a question through which we can calculate kinetic energy. A body of mass 10 kg initially at rest is subjected to a force of 40 Newton. Calculate the kinetic energy acquired by the body in 20 seconds. So we will write the given that. So given that is the mass 10 kg and we have initial velocity 0 because it is at rest. We need to find velocity so that we can find the kinetic energy by half mv square. So v is equal to u plus at from kinetic equation of motion. So just apply the formula, apply the given that, we will get v is equal to 80 meter per second. Now half into 80 meter per second whole square into mass 10, it will give you 32,000 joule of energy. Now let's talk about work done by variable force. So in variable force, forces varies as in the given time and we have to calculate work done. So work done will be equal to the integration of all the work done in the given time. So summation of all work or integration of all work will be calculated in this variable force given as W is equal to summation of Fx dx or del x. Del x is change in displacement and Fx is the function of force with respect to displacement. By applying the limit from initial displacement to final displacement, we will calculate the work done. Now we will talk about work energy theorem. According to the work energy theorem, the change in kinetic energy of a particle is equal to work done on it by net force. So change in kinetic energy means final kinetic energy minus initial kinetic energy will be equal to work done. Work refers to the force and displacement over which it acts. So we can have the change in kinetic energy will be equal to work done, that is work energy theorem for a constant work. Now for constant force, now we will find the work energy theorem for variable force. Here every time force is changing its magnitude, in that condition we can find the differentiation of kinetic energy. So dk upon dt is the differentiation of kinetic energy with respect to time. So formula of kinetic energy is half mv square, so we will differentiate it too. So now we will put the value, we will get dk is equal to f dx. Now we will integrate both the sides to get the relation. So integration of dk from initial kinetic energy to final kinetic energy and f dx from initial displacement to final displacement will give you the same result, that final kinetic energy minus initial kinetic energy is equal to work done. That is also same result we are obtaining for variable force also. Now potential energy is what? Potential energy is defined as the energy possessed by a body by virtue of its position, configuration or shape. Like water stored in a dam, a stone placed on a hill, a stretched bow string are the example of potential energy. So here we are explaining the gravitational potential energy when a body is lifted at a height h against the gravitational force. So work done is calculated by force into displacement. Force is mg and displacement is h. So by multiplying it we are going to get potential energy as mgh. Now when we drop the body will increase its kinetic energy and height is decreased. So potential energy will decrease and kinetic energy will increase. So here we are calculating the final velocity as v square is equal to 2gh, as initial velocity was 0. So we will get v square is equal to 2gh. So v will be is equal to under root 2gh from the given equation we are having. So that's all for this video that of potential energy. Now the next topics we will cover in the next slide. So that's all from my side in this video. So do like, subscribe this channel. Thank you so much. Bless you kids.